Hey guys, I'm going to go ahead and work through the review that we did in class. This is the one, basically we spent all period doing it. So if you were absent or if you just wanted to see something again, here we go. Remember that we just learned about mid-segments. Mid-segments hit the midpoints. So if they tell us that in the problem here, AL is a mid-segment, it's going to hit the midpoints of each side there. And we also know it's parallel to its base. On this particular question, they said find AZ, so that's what we're looking for, if the perimeter is 150. They tell you that ER, this entire side, is 28, so we know each piece is 14. They tell you AL is 2x minus 27.5, and ZR is 2x plus 5. So just a basic mid-segment situation where we know that the mid-segment, 2x minus 27.5, is exactly half. So we need to double that and get 4x minus 55, and that would equal the base, 2x plus 5. So mid-segment properties, it takes two of those to equal one of those, basically. It is exactly half its base. So we solve that, we get 2x equals 60, and we would know 2x equals 60, so x equals 30. All right, well, if x equals 30, we're actually trying to find the length of AZ over here. Remember that the perimeter of everything is 150. So if I take my 30 and plug it in, this would be 65, right? 2 times 30 plus 5. We know this side is 28. So 65 plus 28 would be 93. And then 150 minus 93 would be 57. So we know this entire side is 57 because the perimeter of triangle EZR is 150. So divide that by 2, and that would be how long AZ is. Boom. So that's just using your mid-segment properties. Special segments, here's a few of them. Hey, what do you call the intersection of these segments? These segments being the angle bisector. It's called the end center. And a real quick reminder that the end center is equidistant from what? From all three sides. End, center, inside, equidistant from the sides. End, center, inside. Sing it with me. Equidistant from the sides. All right, so draw angle bisector UX. And so we know it's an angle bisector. Got it. It says if the measure of dux, dux, is 2x minus 10, dux would be this part. Well, that means this is also 2x minus 10. And RUD is 118. Well, RUD is the whole thing. So we know that 2 halves make a whole. So 2x minus 10, double that would be 4x minus 20, and we know that equals the whole thing, 118. So we know 4x equals 138. So let's see, 120 divided by 4, that would be 16 divided by 4, and 2 divided by 4. So 34 and a half, 34.5 would be my x value. And all I did was I took the number 138 and broke it up into numbers that I can easily divide by 4. So 120 plus 16, that's 136. So I had 2 left over. So 120 plus 16 plus 2 is 138. And so the sum of all of those answers would be 138 divided by 4. Hey, what do you call the intersection of these special segments? Well, it's talking about medians. Medians intersect at the centroid. Remember that the centroid is the center of gravity. I don't want to write it out. And it does a 1/3, 2/3 split. Okay, those are properties we need to know. If dy is a median, so I'm going to draw the median dy. That means these two parts are equal. uy is 5x minus 10, and ry is 2x plus 11. So this is a pretty basic median question where 5x minus 10 needs to equal 2x plus 11. So 3x equals 21, and so x equals 7. And then they tell us dr is x plus 28, so this side is x plus 28. Find the doctor. So if you're going to die, right, if you're going to die, you might want to find the doctor. So the doctor equals 7 plus 28, which is 35. Got it. Woo! These are fun. Same triangle. I'm going to go ahead and redraw just another triangle down here. It's the same triangle, new problem. That's triangle D-U-R. All right, it says if G is the centroid, I don't know where to put that, but we'll figure it out. And Q is the midpoint of UD. So here's Q, it's the midpoint of UD. We got it. So if Q is the midpoint of UD, that means that's a median, right? So we got a median. So the centroid is going to be somewhere on there. I don't know where to put it. It doesn't really matter. I'm going to put the centroid right there. And then they tell us RG is 2x plus 8. They tell us RQ, the whole thing, is 9x minus 6. I know my labeling isn't real great here. Now, we need to have some reference for, we need to know how big this is. Now, remember that we have a 1/3, 2/3 split. Remember that the distance to the side is always shorter than to the corner, right? The corner is going to be farther away. The corner is going to be farther away. So 1/3 is half of 2/3. That means that this is going to be half of 2x plus 8. It's going to be 2x plus 8 divided by 2, which is x plus 4. So we know that x plus 4, that's QG, plus 2x plus 8, that's RG, has to equal the whole thing, 9x minus 6, that's QR. So we got to find our QR code here. Let's see, we have 3x plus 12 equals 9x minus 6. So 6x equals 18 and x equals 3, but that's not the final question. They want to know RG, GQ, and RQ. Let's get this real quick. So RG would be 2x plus 8. So that would be 2 times 3. That'd be 6 plus 8 is 14. GQ would be x plus 4. That'd be 3 plus 4. That's 7. And RQ would be 9 times 3, 27. Minus 6 is 21. Does 7 plus 14 add up to 21? Yes. Is 7 1/3 of 21? Yes. Everything checks out. Yes, yes, yes. All right. Hey, what do you call the intersection of these special points or these special segments? This is a perpendicular bisector. That is called the circumcenter. And the circumcenter is equidistant from all 3 vertices. Woo! Hopefully you knew that. It's equidistant from all 3 vertices. All right, so TK is a perpendicular bisector for the side, UD. So it's got to hit the midpoint at a right angle. You got to know these properties. It has to hit a midpoint at a right angle, where K is the midpoint of DU. Measure of TKU. Well, it actually doesn't matter where I put T. If T is over here, TKU is 90. If T is over here, TKU is 90. It doesn't matter where I put point T. They were vague. It doesn't matter. I'm going to put T here. But we know that this is a 90-degree angle. It's a perpendicular bisector. So 4x minus 70 must be 90. So 4x must be 160. X must be 40. Okay. Well, if x is 40, what is 6 times 40? It is 240. So we know this is 240 now. All right, let's keep going. And then they say dk, well, this is dk, is 5y minus 15. And uk, we just said, was 240. So we know that 5y minus 15 has to equal 240 because of it being the midpoint here, right? K has to be the midpoint. So 5y has to equal 255. So 255 divided by 5, I would do 250 divided by 5 and 5 divided by 5. And that is 50 and 1. So 51 is my answer. And that was the question, y equals 51. Find y. All right. Hey, what do you call the intersection of these special segments? These are altitudes. It's called the orthocenter. Orthocenter is used for a few things that we don't care about. Or, I mean, okay, yeah, we don't care about. Don't worry about it. No special properties, so we'll just leave it at orthocenter. It says is the altitude of DUR. Okay, so UM is an altitude for triangle DUR. M is on the side DR. Okay, so we know point M is the intersection of the altitude and the doctor. All right, so we got M on DR there. We got an altitude. We know it starts at a vertex. We know it's perpendicular to the opposite side. Then they tell us DU is equal to UR. Angle MUD is x plus 20. Angle RUD, that's the whole thing. I'm just going to remember, hey, the whole thing is 5x minus 80. How big is angle R? Well, they told us an altitude. So these angles aren't super helpful, but I want us to remember, I'm gonna make a list here. Angle bisector, altitude, perpendicular bisector, median, isosceles triangle. These 5 things. If any 2 of them happen at the same time, you know that all 5 of them happen. And we've talked about this, I don't actually have it pulled up, but we've talked about this in GeoGebra. Here's an example. Like if I know I have a line here that is a median and an altitude, I know it doesn't look like it, but if it's those 2 things, you know it's an angle bisector, you know the triangle is isosceles, you know it's all 5 of these things. What if I give you a triangle and you know that it is an angle bisector and an altitude? Well, then it has to be a median and it has to be isosceles, right? If it's any 2 of these things, you know it has to be all 5 things every time. Every time. And so on this particular one, it says is an altitude. So we have an altitude. These 2 sides are equal. We know it's isosceles. So we know that it's all of the things. So it is an angle bisector. Those are 2 equal parts. So we know that 2x plus 40x, that's just adding those together, has to equal the whole thing, 5x minus 80. So because it was isosceles and an altitude, we knew that it was all 5 of these things. Whew, that's pretty good stuff there. All right, so then we have 3x would equal 120, x equals 40. So if x is 40, this angle is 60, this angle is 90, so this angle is 30. Same thing over here, 60, 90, 30. Or this whole corner is 120, so 180 minus 120 is 60 divided by 2. These angles have to be 30 each. No matter how you do it, the measure of angle R is 30 degrees. I can't write a 3, 30. There we go. But you have to use those isosceles properties for sure. All right, are all of those things the same thing? Let's take a look here real fast. Open this up. All right, here's our special thing. I'm going to go over this again real quick. If I were to draw, right now I know that this triangle is scalene and acute because G, J, I, and H are all inside the triangle. If all my points are inside, I know that it is acute. All of the lines, there's 12 distinct lines. There's 4 blue ones, 4 green ones, 4 pink ones, 4 black ones. That is 12 total lines, so I know it's scalene. If I make it look like this, now it is isosceles. How do I know it's isosceles? Because 4 of the lines overlap at vertex A. Now G, J, I, and H, they're still separate points and they're still inside. So this would be an acute isosceles triangle. But remember, you never have just 2 of the things. Remember the list? You either have all 5 of them, isosceles, angle bisector, median, perpendicular bisector, altitude. You either have all 5 or you just have them individually. But if any 2 occur at the same time, you have all 5. Now notice that the 2 base angles, they're still separate lines, right? Pink and blue and green, they're still separate. But from the vertex angle, they're the same line. If I shifted it this way, now they're the same line from vertex B. This is an obtuse triangle because H and G are outside the triangle. H is the orthocenter, that's where the altitudes hit. G is the circumcenter. What if I make it a right triangle? If I make it a right triangle, remember that H is on the vertex, G is on the midpoint of the hypotenuse. Right on, dude. So the orthocenter and the circumcenter are on the triangle. And then what if I make this an equilateral triangle? Well, all 4 special points became 1 spot. This breaks a lot of sometimes, always, never questions and things like that. It's an orthocenter, a centroid, a circumcenter, and an incenter all at the same time. So for instance, the circumcenter is always equidistant from the vertices, but it is sometimes the center of gravity. Right now, the circumcenter is the center of gravity because it's the same spot as the centroid. So you're going to have to remember things like this to do the problems that we're doing. So in this situation, can these 4 points be the same point? Yes, when it is an equilateral triangle. I don't want to write all that out. Equilateral triangle. Can all these segments be the same segments? Yes, when it is an isosceles triangle. Real quick follow-up. Sometimes, always, or never, is an isosceles triangle equilateral? And the answer is sometimes. So this could still be equilateral. Just because we call it isosceles doesn't mean it's not equilateral. So when it's isosceles, this happens from one corner, the vertex angle, right? If these two sides are equal, it happens from this corner. This corner would be everything. Median, angle bisector, altitude, it's all the things. On an equilateral triangle, it happens from all three corners. All right. Sometimes, always, never. The circumcenter is the center of gravity. That is sometimes. It is always equidistant from the vertices. It is sometimes the center of gravity. A median is perpendicular to the opposite side. Sometimes. On an isosceles triangle, the median, right, if it's isosceles, is also an altitude. It's also perpendicular. What does a median have to do? A median has to hit a midpoint, but it can be perpendicular. Tell me everything you know. Well, we're going to talk about what lines make them, perpendicular bisector, and their special property, and that is equidistant from the vertices. Over here, orthocenter, what lines make them? Altitude, and special properties? None. Incenter, what lines make them? Angle bisectors, and they are equidistant from, what are they equidistant from? It's not vertices. It is equidistant from the sides. Incenter, inside, equidistant from the sides. The centroid is made by the medians, and it is two things. It is the center of gravity. I don't want to write all that out. Center of gravity, and it is a 1/3, 2/3 split. Can all these be the same point? Yes. When does that happen? When are they the same point? It has to be equilateral to be the same point. The points are not the same if it's just isosceles and not equilateral. Do any of these ever exist outside the triangle? Yes. Which ones? Circumcenter, orthocenter. When? When it's obtuse. All right, we've talked about this. Quick break. There's another lesson on this. But how do we find slopes of lines using our new definitions and properties? Let's think about these. I'm not going to do a lot of work here, but let's just talk real fast. If I have triangle JAM, right, they gave us the coordinates for J, A, and M. How would I find the slope of a median, for instance? Well, they call it median JT. So it's median JT. It means it starts at J and it goes to T, and T would be the middle of that side, right? We could put T there. How could I get the slope of this median JT? Well, I know the points J, A, and M. I can use those to get T. T is going to equal A plus M divided by 2. Texas A&M, boo. So T equals A plus M divided by 2. That is X plus X divided by 2. That is Y plus Y divided by 2. So for this problem, we can get point T. Let's do that real quick. We know that point T equals, what do we say? A plus M divided by 2. So for this problem, X plus X would be 6 plus 4 divided by 2. Y plus Y would equal 16 plus negative 6 divided by 2. That it would be 5, 5. Nice. So point T is at 5, 5. The next thing is we need this slope. Well, we know where J is and we know where T is. So can we get the slope of JT now? And the answer is yes. So the slope of JT would equal, now what is slope real quick? That is y2 minus y1 over x2 minus x1. That's one way to think about it. Or it's just how far apart are the y's. Like how do you go from 5 to 10? That's plus 5. That's another way to think about it, but I'll write out the slow way. So 10 minus 5 is my y2 minus y1. Negative 2 minus 5 is my x2 minus x1. And so that would be 5 over negative 7, which simplifies to negative 5 over 7. So we can get the slope of JT after we know where point T is located. All right, next one, find the slope of altitude JQ. So let's go back down here. So it's J again, but it's an altitude this time. So what do we know about altitudes over medians? Altitudes have to be perpendicular to the opposite side. We need a perpendicular slope. We don't know where to put this point. What they call it? JQ? I don't know where Q is. I don't even know if it touches the side. If I were to graph it and it was obtuse, it might not even be on the triangle. But I do know that JQ is perpendicular to AM. These are perpendicular. They make a right angle, so the slopes will be opposite reciprocals. So we're going to get the slope of AM first. We can do that. Slope of AM would equal -6 minus 16 over 4 minus 6. Let's do the subtraction first. That'd be -22 over -2, which is positive 11. Simplify first. So now the slope of JQ would clock in at -1 over 11. And then the last one here, find the slope of perpendicular bisector for side JA. Very similar idea. What does it have to do? It has to be perpendicular at the midpoint. Perpendicular to JA. We know that this perpendicular bisector will be perpendicular to JA. So I'm going to get the slope of JA. Let's see what that is. The slope of JA would be 16 minus 10, y minus y, over 6 minus -2. That is 6 over 8, which reduces to 3/4. So the perpendicular bisector slope would equal -4/3. Let's go. All right, another type of question we're going to have is like, I will give you some sort of description. You got to figure out, would those things described be points or would they be lengths or lines? So for instance, things that could be points, just any type of location, like 3 schools would be points, 3 buildings would be points, 3 cities would be points, 3 people would be points. Like 3 locations of any kind would be 3 points. And what is equidistant from points? The circumcenter. And then things that would be side links, those could be toothpicks, those could be roads, those could be highways, those could be sidewalks, those could be anything that looks like a side or a length. If it has length, and it makes a triangle, that's going to be the end center. So the first one is the owner of amusement park wants to clean up his park. For every 3 rides, he's going to add a garbage can. He wants it equidistant from the 3 closest rides. Well, would rides be points on a map or be lengths on a map? And they would be points. So those would represent points. This would be your circumcenter to be equidistant from the points. Mia's installing a triangular counter. If she wants to put the sink at a location equidistant from all 3 sides, where should she put it? Well, they said the word sides. So that is the end center. And then a carpenter's designing a triangular table with 1 leg. Where should she put the leg to properly balance the table? That's the center of gravity. That's the centroid. This is a lot of points. You miss those, you're going to miss a lot of points. Make sure you understand why I just gave the answers I did, the difference between points, sides, and a center of gravity. All right, 2 last questions. There's a clerk at a butcher shop. He is 5 feet 10 inches tall, wears size 13 shoes. What does he weigh? What does he weigh? It's not me. Someone asked if it was me earlier. I weigh 207 right now, so I'm actually pretty low for me. I'm 6'2", almost 6'3", and I weigh 207, which is not great. I can do better. But this guy weighs, what does he weigh? He weighs meat. Think about it. You'll get there. How much dirt is there in a hole that measures 2 by 3 by 4? How much dirt is in a what? A hole. There's going to be none. It's a hole. Okay. All right, guys. Have fun. Love y'all.